Alrighty, so for step number 2 then is to create a Boolean raster showing those areas that lie beyond 300 meters from a primary or secondary road. So the primary and secondary roads, picture those in a national forest setting of being those more major roads. They're paved roads, cars are going fast, and so you don't want to have Bighorn sheep too close to those roads. And what she's saying is she doesn't want anything within the 300 meters of those roads. So we want to exclude those and then keep everything else. So let's bring in the necessary GIS layers for that one. As you can imagine, what we want for that is a GIS layer of roads. So let's see what we've got. We can close the tables here. Back to add data. And then we need to go to where the data are stored. I have them on my 273 folder, GIS class, MGIS data, Black Hills, and then the Sturgis geodatabase, and they're probably going to be in features, and we're looking for the U.S. Forest Service roads. And it's kind of cryptic. It's USFSRDS will be what you're looking for there, and go ahead and add that in. I'm going to turn off this raster, and there's the roads. If I want to symbolize this in a way that looks more like roads, I might just switch this to black lines instead of blue. They look like rivers. Okay, so there's all the roads. We want anything outside of 300 meters. And so there's a really, really cool tool within the raster tool set. This is the tool that my student used before, trying to find those most remote places in an area. The whole United States, she was trying to find the place you could hike to farthest away from any given road. And there's this distance raster tool that it overlays a raster grid, a 30-meter raster grid in this case. And what it does is if you had a graph paper and you took a ruler from the cell that may line right here, you go to the nearest road, and then you just measure what's the linear distance between that point and the nearest feature of interest. And so it'll look kind of like bullseyes. If you just had one point in there, like one airport, it would just be a radiating set of colors. But in this case, it's going to be these radiating colors that are going away from these roads is what it will look like. All right, so it's called the Euclidean distance tool, and our environments are already set to the default extent and the 30-meter cell size. So we need to go back to our toolbox, and then if we do distance here, let's see the options here. The one that we want, it's kind of Euclidean is just a fancy term for like a crow flies a straight line distance. So you can have different distance measures in GIS. You can have distance as along roads or along rivers if the curved path is important. But Euclidean distance is just simply the straight line distance. And that's all she wants for this one is how far away from a road are you. So we're going to run the Euclidean distance tool. The input for this is going to be our roads. The output will be our, this will be a fine name. I'm just going to name it to the Euclidean distance, kind of abbreviated. And by the way, the output from this will be a raster. Even though the input from this is vector lines, its output's going to be raster. Input or feature barrier data, we don't have anything like that. We're going to use 30-meter cell size. And we can just run this tool as is. This output cell size is 30. And what we expect this to look like in the end is where the areas that are furthest from the road will get certain colors. Anything close to the roads will all have values that are, the greens in this case are close. Why we end up with these colors is that way over here, this far corner is the furthest from any roads. It's just because the GIS layer didn't have any roads out there. But you can kind of see here, as you're further and further away from the roads, they're getting more and more of those yellows, and the greens are close by. All right, so to turn this into a Boolean, think about how do we turn this layer that where every raster cell is the number of meters away from the roads, how do we turn this into either a 1 or a 0? Meets the condition or it doesn't? If you guys think about what tool might we use to turn this into 1s and 0s? Any thoughts on that? Yeah, that's going to be the reclassify tool again. I like to streamline this process by making my map look like I want it to look. And right now it's just this stretched. But if I right-click on this and go to symbology, instead of stretched, I want this to be in classified. I only want it in 2 groups classified. There's 5 groups classified, but if I just want this in 2 groups, I can switch it to 5 to 2, and then I can change the threshold here to the 300 meters, and that's what my output map's going to look like. Is going to be a Boolean that looks like this. Anything in red, in this case, meets the condition. It's outside of 300 meters. Anything in yellow is too close to a road and doesn't meet that condition. We still have to run the tool, and so we'll go over here to the geoprocessing tools. We'll go back, type in reclassify. The input raster for this is going to be the Euclidean distance of roads. The value is the one we want. Anything that's from 0 to 3, the output from this, or 300, remember the output from this is the one, this doesn't meet the condition, right? It's too close to a road, so we want to switch the new value to a 0 here. Anything that's 300 all the way up to the highest number, that does meet the condition, so we want that to be a 1. In this case, we're going to leave no data as no data. The output from this is going to essentially be, it's going to be our answer for question step 2. Step 2 result. This one has to do with the roads. This will run that tool, and we'll end up with a raster that has 2 potential values. Anything that meets the condition are 1s. Those are going to be our green areas versus the areas that are 0s as too close to a road to be useful. When we resume class next time, we're going to then proceed with the areas that are steep. And then we'll do our final, it's the easiest step of all of it is that final overlay where you get all 3 of those layers to come together to see those areas that are suitable. And again, we'll anticipate that we get little tiny polygon, little clusters that are too small. The last step then we'll do is separate the ones that are under 3 square kilometers from the ones over 3 kilometers, and we'll get our answer to that last question as well. So we'll pick that up next time. So come prepared next time, guys. If you didn't present today, just come prepared. We'll have you here for another 4 or 5 people next time, and we'll finish those up on Monday as well. All right, thanks to those who did present today. Have a good rest of your afternoon.